Hello everyone, welcome to Catalysis by Vedantu. If I'm audible and visible, please write yo in the chat box, you know the drill. So as you can notice, today something different and something new is happening. Now this is the very first time that I'm using this smartboard at home. So the interface, the video, it might be a little glitchy, but I hope it is nice, yeah. So my dear friends, we will begin today's class with this question that I had given you for the homework. Remember, ये अपन ने homework में लिया था question. We had seen this question in the previous class. So I just hope everything goes fine today because it's been a difficult task setting all of this up. Yeah, तो चलो बढ़िया है. Let's hope it goes good today. Yeah, I can see a lot of people are happy that we have the smart board all over here. Awesome. So people, this is the first question. This was the homework question. तो इसको कैसे करेंगे सोच के देखते हैं. Let's read the question once again. I'll go out of the frame. A, B and C are hydroxy compounds of the elements X, Y and Z respectively. X, Y and Z are in the same period of the periodic table. A gives an aqueous solution of pH less than 7. तो हो क्या रहा है? That A, B and C are related to X, Y and Z. Yeah. Now we know for a fact that A over here is acidic. Yeah. B over here, as it is written over here, it reacts with both strong acid and strong alkali. So that means that B is amphoteric. I'll just write ampho over here. And C, as it's given in the question, this is basic in nature or alkaline. ठीक है? Great. Now I can derive it by corollary that X would be a non-metal. Yeah. Y would be somewhere in the middle. Maybe a metalloid kind of a species. And Z, क्या होगा यहाँ पे? Z would be a metal. That is what's going on over here, right? Now it is given that you know. So now it is given that X, Y and Z are in the same period of the periodic table. Yes. So अब let's look at the options that we have. These three elements are metals? Definitely not. All three of them are not metals. Only Z is a metal. Yeah. The second one says the electronegativities decrease from X to Y to Z. X to Y to Z electronegativity will decrease. That's absolutely correct because non-metals will have high electronegativity, isn't it? Non-metals की electronegativity ज़्यादा रहेगी. So my dear friends, electronegativities decrease from X to Y to Z. That is absolutely correct. X will have higher electronegativity than Y. Then you will have Z. Then you have atomic radius decreases in the order of X, Y and Z. That is incorrect. Isn't it? गलत है ना? Atomic radius, it says, decreases in the order of X to Y to Z. Metal will be the largest. If they are from the same period, this guy is going to be the largest, isn't it? Because when you go down a period, the effective nuclear charge increases, so the non-metal will be smaller. Fluorine size is smaller than the size of lithium. Is that fine? Cool. So last one says X, Y and Z could be phosphorus, aluminium and sodium respectively. So this could be phosphorus, this could be aluminium and this could be sodium respectively. I think this is correct. I think that part is absolutely fine. Yes, बिल्कुल सही बात है. Could be possible. This is a non-metal, this is in the middle and this is the largest, that is metal. So that looks absolutely fine to me. So option number D can also be correct. So my correct answer for this question would be 2 and 4. Is that fine? People? सही है क्या? Is that okay? Yeah. Awesome. So Raju bhai is also saying that 2 and 4 is the answer, right? So let me try to show you guys the people who gave me the correct answer in the previous class. Just give me 2 minutes. Now the setup is different. Everything takes a little more time to open up and everything. 2 minutes de do. Let me figure out how to show you the comments of the previous class. Chalo try karte hain. I don't know if it will work. Okay, yeah. So I'm here on the side. Hello. And these are the comments. So if I sort these comments by newest first, yeah, a lot of people I think have given the correct answer. That is awesome. Devesh is saying, sir, happy belated Guru Purnima. Thank you so much, man. Okay, comments are loading up, people. Just give me a minute. हाँ जी, बढ़िया. So ये comment ऊपर कर देते हैं जाके. हाँ. So okay. Shravanti is saying 2 and 4 are correct. Absolutely correct, Shravanti. Sohit is saying, can you add English captions? Bro, caption adding is a very tall procedure. So to add captions for a 1 hour, 2 hour long class, it'll take like 5 hours on its own. So that's why it's kind of impractical to do so. DD Matix, very nice, man. Abhishkar, good job. Sainath and other Sainath, both Sainath. I think you missed something. Yeah. And Mithali, very nice. Kanav, I think you missed something again. Hanuman, very good. Sauradipta, very good. Rishik, very nice. Dhan Gamer, very good. Vishruta, awesome. Jyom Pandey, very good. So I have taken a few names, and yeah, you know that we can't take everyone's names in this class. So I hope you understand. But if you got the correct answer, that is absolutely correct. ठीक है, अगर आंसर सही आया तो बिल्कुल सही बात है. Very nice. Now people, let us move on into today's class. So today we will discuss some concepts, okay, that stem out of the periodic properties chapter. Okay, we will discuss some concepts that stem out of the periodic properties chapter, and it's very important for us to understand these concepts. ठीक है, अगर ये समझ पाओगे तो बहुत अच्छी बात है. Let's try to see. Before I tell you those concepts, yeah, please make sure you enroll to these courses. Okay, as you know that Vedantu offers you full-time courses as well, because right now in the world offline coaching is not possible. Yes, so online coaching is what all of us will have to do, and since Vedantu has been doing it for a very long time, I suggest you to join these courses. Okay, so full courses at Vedantu, these are the links. I will move towards this side. एक बार देख लो, ये रहे links. Okay, so you just have to go to vdnt.in/ytpro. All the information is there. The prices are as low as 2,500 per month. ठीक है, the prices are so low. If you go to an offline coaching, you know they take like lakhs of rupees per year, but we are taking only 2,500 rupees per month. That is the cheapest plan. So in case you want to see these, the links are in the description box down below, and these are the coupon codes. एक बार check कर लेना if this helps you. Amazing. चलो, you will get all sorts of things, live classes and tests and study materials, assignments, everything. Chalo. So my dear friends, now what I have on this page is that we have to define the order of acidity. पढ़ रहे हो ये क्या है? Order of acidity. Can you guys tell me what does acidity mean? Can you guys tell me what do we mean by acidity? Acidity का मतलब क्या है? Let's try to write it over here. Okay. What is an acid? An acid is something that gives us an H positive. Acid gives us H positive, isn't it? That's what the definition of an acid is, right? Now, my dear friends, can I say that something will be more acidic? Okay, something is more acidic if I can remove my hydrogen easily. Isn't it? Acid gives us H positive, and it's going to be more acidic if I can remove the H positive easily, right? That's what the meaning of an acid is. So now over here we need to define the order of acidity. Essentially, in each of these questions there are multiple species, 4 things to compare: HF, HCl, HBr, HI, 4 things to compare, 4 to compare, 4 to compare. So we need to understand how to figure out which one is more acidic in nature. ठीक है, करेंगे, shall we? चलो, let's try to do it. तो दोस्तों अब हो क्या रहा है यहाँ पे? Okay, if we try to define the order of acidity, look at the first case: HF, HCl, HBr and HI. Right? I'll give you a very simple hint. पहला logic तो बहुत simple है. The first logic is very simple. What you have to do is, I'll just tell you logic number 1. Simply understand this, that non-metal is acidic, Yeah, you remember this? Non-metal is acidic. Now, my dear friends, if I say that something is more non-metallic, it will be more acidic. Can I say that? If you agree with me, write yes in the chat box. Batao. If you agree with me, write yes in the chat box. I'll just drink some water. Is that fine? Do you agree with this logic? Okay, awesome. So now if you agree with this logic, can you guys understand over here which one is the most non-metallic? Out of HF, HCl, HBr and HI, do you realize that HI is the most non-metallic? Wait, that is not true. अगर यहां देखा जाए तो फ्लोरीन इज मोस्ट नॉन मेटालिक. And this implies that HF should be the strongest acid, isn't it? This implies that HF should be the strongest acid. है ना जी? My dear friends, a lot of people use this logic and make silly mistakes. ठीक है? This logic that I am telling you over here is actually incorrect. Okay? This logic is, I would say, not always applicable. ठीक है, ये याद रखना. दिस लॉजिक इज नॉट ऑलवेज एप्लीकेबल. प्लीज मेक श्योर यू रिमेंबर दिस. ठीक है, दिस लॉजिक इज नॉट ऑलवेज एप्लीकेबल. इस लॉजिक को हमेशा मत लगाना. दिस लॉजिक इज एप्लीकेबल समटाइम्स, इट्स नॉट एप्लीकेबल अ लॉट ऑफ टाइम्स. दिस लॉजिक इज नॉट एप्लीकेबल ओवर हियर. भूल जाओ इसको. फॉरगेट अबाउट इट फॉर नाउ. ठीक है, अच्छा भूल जाए. फॉरगॉट अबाउट इट. सो व्हाट शुड वी डू? What should we do instead? What's the better way to think about it? Let me try to explain that to you. My dear friends, there are two cases that we need to consider. Over here in the first question, you have the comparison between fluorine, chlorine, bromine and iodine. Yes, this is very important piece of information. Questions from these come directly in examination, so please make sure you pay attention. Yeah, so fluorine, chlorine, bromine, iodine, ये तो अपने को चमकता है, are from the same group. Can I say that they are from the same group? Yes, of course, all of them are halogens, right? Now, the other thing that we have over here, we are trying to compare species that belong to carbon, nitrogen, oxygen and fluorine. So over here I would write that these belong to the same period, isn't it? ये same period के हो गए. Same group, same period. Understood the difference between these two cases? Yes, difference तो समझ आ गया होगा. Now my dear friends, the things that we need to consider in these two cases are different. Please make sure you note this down. ठीक है, ये सब note करने का है. When you are in the same group, okay, when you are in the same group, this is something that you need to remember. When you are in the same group, size difference matters. Okay, size difference matters. Do you realize fluorine, chlorine, bromine, iodine? Iodine is going to be very huge. Yeah, iodine over here, so very huge structure. Fluorine on the other hand, compared to iodine, will be a very small structure. So whenever you are comparing things in a group, okay, whenever you are comparing things in a group, size difference matters a lot. ठीक है, ठीक है, size difference matters very much. All right, size difference matters very much. Now, how do we apply this size difference over here? For applying size difference over here, there is a thing that I will teach you. It's just a sentence, okay? Like bonds better with, okay, ये मेरा with like. Have you heard that statement? Like dissolves like. You heard that statement, right? So again, the statement that I'm telling you over here is like bonds better with like. देखो, if I talk about hydrogen, hydrogen over here is a small species. Do you realize hydrogen is a very small species, isn't it? Right? Now, over here, if I have fluorine, fluorine is also small. ये green pen शायद दिखेगा नहीं. Fluorine is also small. Yes. So hydrogen and fluorine, they bond together really well. Okay, they bond together really well. I'll just make a smiley over here. ठीक है? These guys are very happy bonding with each other. All right. Now on the other hand, okay, on the other hand, if I take hydrogen with iodine, iodine is very huge compared to hydrogen compared to fluorine. So over here, their bond is going to be not so good. When the bond is not good, when it is easy for you to break the bond, do you realize that will have the most amount of acidity? Do you realize? अच्छा ये हटा देते हैं यहाँ से. This information we already know. We kept it in our mind. You can pause the video anywhere, by the way. It's on YouTube. So the information that we need to remember is that this bond is easy to break. Isn't it? So if HI's bond is easier to break, if it's easier to just break apart this bond because of their size difference, what happens is that there is an electronic cloud for hydrogen, there is an electronic cloud for iodine. Now when they bond with each other, the electronic cloud of hydrogen is not compatible with the electronic cloud of iodine that well. इतने अच्छे से आपस में bond नहीं कर पाते. We'll discuss more about these ideas in the chapter of chemical bonding. Okay. Otherwise, what we need to understand right now is because of the size difference, the bond is very easy to break. Therefore, this is going to be an acidic species. HI is going to be very, very, very acidic. Okay. So, my dear friends, over here, what will be the order of acidity? क्या order हो जाएगा? Order of acidity will be HI is most acidic. Then you have HBr, then you have HCl, then you have HF. So, what do we need to remember over here? That in the same group, okay, whenever we are talking about the same group, we are talking about size difference in the same group. Okay, size is what matters inside a group. My dear friends, please make sure you keep this in your mind and write it down. Okay. Sai Chetan is asking, how should we actually solve MS Chauhan? Just open the book and solve it, bro. Then. Is there any other way of solving questions? ठीक है, चलो, बढ़िया. ये तो समझ आ गया. This is awesome. Now, let us move on to the next case. That is this one. इसमें देखते हैं क्या हो रहा है. Okay, let's try to move into this particular case. Now, carbon, nitrogen, oxygen and fluorine, these four, my dear friends, belong to the same period. Their size differences are not very significant. Okay, when you are in the same period, the size differences do exist, but they are not very significant and they won't really affect the bonding parameters. Bonding पे size difference का ज़्यादा फर्क नहीं पड़ेगा. ठीक है? So what should we consider over here then? What should we consider over here then? We can consider metallicity, non-metallicity, but to talk about it in a little better manner, we over here should consider the electronegativity difference. ये board थोड़ा हिलता है. Yeah. We should consider the electronegativity. ठीक लिखा मैंने? Electronegativity difference. ठीक है? This is what we need to consider over here. Let me give you the examples of the cases of carbon and fluorine. ठीक है? Let's say we have a bond of hydrogen with carbon and we have a bond of hydrogen with fluorine. Let's try to write all of their electronegativities. क्या होंगे electronegativities? Hydrogen's electronegativity, if you remember, is 2.1. Carbon's electronegativity is 2.5. Fluorine's electronegativity is 4.0. So if I have to make the bond over here, ठीक है, इन दोनों के अगर मैं बॉन्ड बनाने की कोशिश करूं यहाँ पे, In the case of hydrogen and carbon, the electrons are almost in the middle, a little bit towards carbon. Yeah, let's say this is the case for electrons in the bond of hydrogen and carbon, slightly towards carbon because a little more electronegativity. Yeah. But now on the other hand, my dear friends, in the case of hydrogen and fluorine, do you realize that the electrons are almost towards fluorine? इतना समझ आ रहा है? This image is something that we've already discussed in this chapter. So I'm pretty sure that this is clear to all of you. Yeah, that hydrogen and carbon 2.1, 2.5, hydrogen fluorine 2.1, 4.0. So the electrons are more towards fluorine. And now, let us imagine we are breaking their bonds apart. Yeah, let us imagine that we are breaking their bonds apart. If we break their bonds apart, what do we need to make? We need to make H positive, carbon negative. We need to make H positive, F negative. Now, the next statement that I'm going to say, listen to it very carefully. जो अगली statement मैं बताने वाला हूँ बहुत ध्यान से सुनने का जरूरी है. The thing is, over here between hydrogen and fluorine, do you realize that fluorine already has the electrons towards itself? Fluorine already has the electrons towards itself. Fluorine के पास पहले से ही वो इलेक्ट्रॉन पड़े हैं, पास में है fluorine के. So if I break apart this bond, do you realize it is easier for me to create the F negative species? Do you see that? The arrow might be a little not so visible. Do you understand why this will become fluorine negative? See, these two electrons, when they are bonding with each other, one electron comes from hydrogen. Let's make it in red color. One electron comes from hydrogen originally. One electron comes from fluorine originally. These two bond with each other. Yes. Now, if you give this extra electron to fluorine, that will turn into a negatively charged species. अगर मैंने एक एक्स्ट्रा इलेक्ट्रॉन फ्लोरीन को दे दिया तो वो नेगेटिवली चार्ज हो जाएगा, है ना जी? बात समझते हो? So now if fluorine already has the electrons towards itself, it can easily capture them and run away. Isn't it? Imagine like something like this. Okay, एक घटिया सा सिचुएशन देता हूं मैं आपको. Person number A, person number B, and the task is to take a ball and run away. What if the ball is already towards B? Okay, this is a very weird basketball. Okay, looks like a basketball. But if the ball is already close to person number B can easily snatch it and run away, right? Similarly, if I talk about the bonding of hydrogen versus fluorine, the electrons are already towards fluorine, so this can easily capture them and run away to become F negative. When you throw them in water, water has a dielectric constant. Have you read the fact that water is a universal solvent? Why? Because it has a very high dielectric constant. We'll learn about that idea more in chemical bonding. But the thing is, when you put this in water, water will be able to break it apart easily because F already has the electrons towards itself. Got it? So my dear friends, over here, what is the conclusion? The conclusion is, I will try to write, in a period. Okay, in a period, generally more electronegativity difference implies more acidity. Okay, got it? In a period, more electronegativity difference implies more acidity. Fine. So in the second case, the acidity for CH4, the acidity for methane is going to be the least. Then ammonia, then water, then HF. This is the order of acidity. So in the first case, this was the order of acidity. वहाँ पे अपन ने consider किया size because they belong to the same group. In the second case, they belong to the same period. Yes. So over here, you have to talk about electronegativity difference. Delta En is what matters over here. Got it? Chamka? Fine. I hope you understood. So my dear friends, quickly, can you tell me the answers for these two species? For these two cases, can you tell me the answers? H2O, H2S, H2Se and H2Te. Oxygen family. Size difference matters. Most acidic will be the bond with tellurium, because tellurium and hydrogen's bond is not that strong because of their size difference. Phosphorus, sulfur and chlorine. Again, chlorine and hydrogen have most amount of electronegativity difference. So this is going to be the acidity order. My dear friends, please make sure you note this down. Okay? ये जो भी मैंने बताया, please make sure you note all of it down. Very important for you to note it down. Okay? ठीक है? Ishan is saying this board is better than the studio board. I don't know, bro. It's a very small board. काफ़ी जोर लग गया यार इसको सेटअप करने में. So right now I'm actually using an external software to reduce the brightness of this board, because if the board runs on its own brightness, then I look black and the board looks white. So I have to do a lot of weird things. And one more thing is that you can see the light source is right here. This side of my face is glowing quite a lot, because if I keep the light source in the front, this has a lot of glare. तो इस पे से सब कुछ रिफ्लेक्ट करता है and looks very bad. So it has taken me a lot of time to set up this whiteboard. Also, if the electricity goes away, the whiteboard will stop working. We'll have to wait for the power backup to turn up. The power backup in my house takes like 10 seconds to come up. So हैं अभी थोड़े थोड़े प्रॉब्लम्स जो सॉर्ट आउट करने हैं. राजू, yes, I am not going to provide the PDF, bro. Yeah. So technically speaking, this year I'm going to be working from home. मतलब दिसंबर तक तो पक्का ये सेटअप यहीं रहेगा. चलो चलो, something is better than nothing. I think it's not a very bad situation. बढ़िया है. चलो, nice. I hope you guys wrote this down. So ये याद रखने का again. Now people, the same application, ठीक है? We are trying to use the same idea over here, and we are trying to decide difference between bond energy and bond length. ठीक है? What does this mean? See people, bond energy. What does this mean? Let's try to understand what is bond energy. Bond length is simple, but what is bond energy? See, bond energy is the energy required, okay, to break a bond. Okay, what is bond energy? In very simple terms, bond energy is the energy required to break a bond. My dear friends, do you realize that more bond energy, BE represents more bond energy. More bond energy essentially tells you that the bond is more stable. Yes. More bond energy implies that the bond is more stable. If you have to provide a lot of energy to break that bond, of course that bond is very stable. Now, keeping this idea in mind that more bond energy implies a more stable bond, my dear friends, can I say that more stable bond will be a shorter bond? Can I say that? A very simple human analogy is, if two people like each other, they will want to stay close to each other. If two people don't like each other, they will want to stay as far as they can from each other. So is this statement correct? More bond energy implies more stable is the bond. If the stability of the bond is more, if they are happy with each other, they will stay closer to each other. Isn't it? So what can I say? Shorter bond implies less bond length. More bond energy, more stability, shorter bond, less bond length. So what did we understand from here? Look at these two things that we've written. ये दो चीजों पे ध्यान दो, forget everything else. What can I say? I can say, मैं ये बोल सकता हूं that bond energy is inversely proportional to bond length. Isn't it? More bond energy, stable bond, closer. This is the result. ठीक है, more bond energy will imply lesser bond length. Great. So over here, my dear friends, can we write the order? Can we write the order of bond length? We understood that because of the size differences between HF, HCl, HBr and HI, HI was the weakest bond. So my dear friends, over here bond length will be largest for HI, then HBr, then HCl, then HF. Bond energy, again the opposite order will be true. HF will be the smallest bond, HCl, HI. चमक गया अब तो. Yeah, that is pretty simple now. Again, let's discuss over here. Bond length. Stronger bond, shorter length. Yes. Easier to break the HF bond compared to the CH4 bond. Bond energy. Please make sure you note this down. Very simple idea, and for all of you who have just joined the class, my dear friends, I have explained this logic on the previous page. ठीक है? So Deccan Gamer is saying like Thoko, thank you bro. Aaron is saying I like the old screen. Yeah man, preferences differ for everyone. अब ये दे दिया है सेटअप ऑफिस वालों ने तो करना तो पड़ेगा ना इस पे काम. Even I like to sit down and take classes. That's a little more chilled out. But again, I think a lot of people enjoy the whiteboard setup. And I can see there are a lot of more viewers today than my earlier periodic table classes. So I think people are enjoying. Raju, don't worry, bro. Raju is saying, I want to be like you in chemistry. Please help, bro. NCRT पढ़ो, solve करो. You will come a very good way. Achha, by the way, people, you tell me, which setup do you prefer, the smart board or the sitting setup? So this is the new setup. The other setup which I used to do till now on this channel is the old setup. Which one do you prefer, new or old? Tell me in the chat box. New लिखो या old लिखो, बताओ. Tell me. Amar, it did happen in the beginning of the class, bro. Etikalla Nishant Reddy is asking what's the daily schedule. I'll tell you, bro. I'll tell you what's the daily schedule. So the schedule is something like this for all of you who are new to the channel. This is the schedule. For 2020 students, I have classes from Monday to Friday at 8:30 p.m. For 2021 students, the classes are on Monday, Wednesday and Thursday at 7 p.m. And for most of you guys, I hope, who are going to give the 2022 exams, the classes are on Tuesday, Thursday, यहाँ पे गलत कर दिया मैंने, Monday, Wednesday and Friday, okay? So 2021 के लिए Monday, Wednesday, Friday and Tuesday, Thursday, Saturday at 7 p.m. is the schedule for 2022 students. Okay, so a lot of people are saying they like the old setup. A lot of people say they like the new setup. Old, new, both. अच्छा, समीक्षा is saying ये setup सारे चलाते हैं, आपका setup अलग है. Interesting. Smart board, new, old. Snehallata, no, it's not sponsored by anyone. And that bottle is Aquafina, not Kinley, I think. Mixed reviews. काफी मतलब it's almost a 50-50 situation, I think. Anyway, बढ़िया है. इसकी भी आदत पड़ जाएगी. We'll keep switching then. We'll do some classes on the old setup as well. Chalo. Now, my dear friends, this piece of information that I'm going to discuss with you, this is something that will be very helpful when you are talking about the chapters of P block. ठीक है, P block का जो chapter है उसमें ये बहुत काम का है. So let us try to understand what's going on over here. We are trying to define what is inert pair effect. ठीक है. Can we write down the electronic configuration of lead? Lead का electronic configuration बता सकते हो मेरे को क्या होता है? Can you tell me what's the electronic configuration of lead? Where is lead? In the carbon family. Yes, carbon family. So what is the period in which lead is present? This is second period, third, 4th, 5th and 6th period. Yeah. So as I've taught you in the first class of periodic properties chapter, 6th period hai. So the electronic configuration for lead will be 6p2, isn't it? This is a P2 line है ना, P2 group. So 6p2 और यहाँ पे आ जाएगा 6s2. Got it? हाँ, वो अपने आप क्लियर हो जाएगी. द कैमरा हैज ऑटो फोकस, अपने आप क्लियर हो जाएगी स्क्रीन. डोंट वरी अबाउट दैट. ठीक है, चलो. सी, आई स्टे अलोन इन माई हाउस, सो इफ यू हैव अ प्रॉब्लम विद ऑटो फोकस, then I will have to hire someone to sit here and change the focus all the time. Auto focus है, थोड़ा सा adjust. Okay. So 6s2, 6p2, this is the case. Now, my dear friends, over here, if I write the inner electronic configuration behind 6s2, 6p2, what is going to be there? There will be a 5d10. है ना, 5 में कुछ तो होगा. There will also be a 4f14. My dear friends, because of the 4f14 and 5d10 electron presence, because of the presence of 4f14 and 5d10 electrons, my dear friends, over here the thing is 4f14 और 5d10 electrons होने की वजह से there is a poor screening effect. Yes, चमकता है. Because there is a poor screening effect of 4f14 and 5d10 orbitals, okay, this implies that the effective nuclear charge is high. Yes, effective nuclear charge is discussed for the valence electrons. So effective nuclear charge is very high. So my dear friends, what ends up happening is, see, s orbitals are close to the nucleus, spherical. P orbitals are lobes, so they are a little farther from the nucleus compared to s orbitals. S orbital थोड़ा पास रहेगा न्यूक्लियस के. So my dear friends, because of this high effective nuclear charge, what happens is that these 6s2 electrons, okay, these 6s2 electrons are held tightly by the atom. Okay, these are held tightly. ठीक है, these 6s2 electrons are held tightly because there is so much effective nuclear charge. So comparing them to 6p2 electrons, the 6s2 electrons are held tightly. These 6s2 electrons are essentially reluctant to react. ठीक है, मेरी हैंडराइटिंग बहुत ही प्यारी सी है. Reluctant to react. ठीक है, got it? So these 6s2 electrons are reluctant to react. They don't want to react because they are held very tightly by the nucleus because of its high effective nuclear charge, because of the poor screening of 4f14 and 5d10 orbitals. So what happens experimentally is, this is the experiment. Okay, this is what is noted in the experiment. ठीक है, ये ऐसी चीज है जो एक्सपेरिमेंट में देखी जाती है. क्वेश्चंस थोड़ी देर में करते हैं, रुको. हाँ, so this is what we notice whenever we do an experiment. Let's try to read what is written over there. The reluctance of ns electrons to participate in chemical reactions is known as the inert pair effect. ठीक है, the reluctance of ns electrons to participate in a chemical reaction is known as the inert pair effect. What are the facts? AlCl3 exists, BCl3 exists, SiO2 exists. ठीक है, what are the oxidation states over here? AlCl3 में +3 oxidation state for aluminium. Aluminium is in a +3 state, isn't it? Boron is in a +3 state. Silicon over here is in a +4 state. But these species do not exist. Okay, aluminium with a +1 does not exist. Boron with a +1 does not exist. SiO with a +1, these do not exist. Okay, SiO +2 हो जाएगा यहाँ पे. These do not exist. ठीक है, +1, +1, +2 for aluminium, boron and silicon do not exist. But when you go down the group, Raju is saying when you change the page, the screen fluctuates and not visible for some time. I know, Raju, as I said, it's the first day, So I need to figure out how to fix these problems. Maybe I'll change the autofocus sensitivity so that it doesn't change a lot. Anyway, धीरे धीरे सब figure out कर लेंगे यार. चलो, तो यहाँ पे क्या हो रहा है? When you go down the group, okay? When you go to thallium and lead, let me make these specific periods for you. I mean, let me make these specific groups for you. So what groups are we talking about? We are talking about the boron family. Yes, and we are also talking about the carbon family. Cool. So what is being said is that the above elements, the elements on the top, they show only a higher oxidation state. Yeah, these would like to show a +2 oxidation state. These would like to show a +3 oxidation state. These would like to show a +4 oxidation state, as we understood over here, है ना? +3 +4 देखना चाहेंगे हम उसमें. But thallium and lead, this can show +3 and +1 both. This can show +4 and +2 both. Both of them are observed in nature. Both of them are observed in nature. So my dear friends, let's just try to write down, okay, let's just try to write down the electronic configurations of thallium +3, thallium +1. ठीक है, इनकी इलेक्ट्रॉनिक कन्फिगरेशन लिखो. ऑल्सो राइट द इलेक्ट्रॉनिक कन्फिगरेशन ऑफ लेड +3 एंड लेड +1. सॉरी, यहाँ पे लेड, अरे यार, हाँ, lead +4 and lead +2. Can we write this? This essentially is going to be a 6s0, 6p0. You can write all your 5d10, 4f14, doesn't matter. This is what? 6s2, 6p0. Over here, this is a 6s0, 6p0. This guy is 6s2, 6p0. Isn't it? सारा गायब हो गया. वेलकम टू द वाइट बोर्ड. चीजें गायब हो जाती है. Anyway, so the thing is, it is found out that these species are more stable. Both of these species, if you notice carefully, are 6s2 species. Why are these more stable? Because we understood on the previous page that the 6s2 electrons are held tightly by the nucleus. Yeah, these are held tightly by the nucleus because of the high effective nuclear charge, because poor screening effect of your inner orbitals. Yeah, D and F orbital के poor screening effect की वजह से. Fine. So now my dear friends, since these are held tightly, they do not want to react. Yeah, they do not want to react. So my dear friends, if they don't want to react, what does this mean? It means that these two electrons, this pair of electrons is inert. That's what we are saying. Inert pair effect. Yes. बात बनी? Got it? So because these are held tightly by the nucleus, it's called the inert pair effect. Got it? चलो. Please make sure you write it down. And make sure you read this statement as well. That's at the bottom. For period 6 in group 13, 14 and 15, the lower valencies are stable. Okay, the lower oxidation states +1, +2, these are more stable. ठीक है? Got it? Ranjan is saying, can you teach inductive effect in detail? Ranjan, we've already done that, bro. पहले ही हो चुका है वो यार. राजू, rewind the class and watch, bro. राजू प्लीज थोड़ा सा रिवाइंड करके देखने का. दोस्त हो क्या रहा है कि पुअर स्क्रीनिंग इफेक्ट है ना 4F14 और 5D10 का, तो उसकी वजह से 6S2 अच्छे से पकड़े हुए हैं एटम ने, रिएक्ट नहीं करना चाहते. रिएक्ट नहीं करना चाहते का मतलब इनर्ट है, इनर्ट पेयर इफेक्ट. ओके, एज सिंपल एज दैट, नथिंग टू कॉम्प्लिकेटेड अबाउट इट. इनर्ट पेयर इफेक्ट, वेरी सिंपल. चलो जी. सो नाउ माय डियर फ्रेंड्स, फॉर द नेक्स्ट 10 मिनट्स लेट्स क्विकली सॉल्व सम क्वेश्चंस. वेरी इंटरेस्टिंग, वेरी गुड क्वेश्चंस. चलो करके देखते हैं. फर्स्ट केस, which one is the best oxidizing agent? My dear friends, quickly tell me, which one of these is the best oxidizing agent? Oxidizing agent बोले तो what do we mean by oxidizing agent? Oxidizing agent means it takes electrons from the other species. Takes electrons. Essentially, it gets reduced. Isn't it? It gets reduced on its own. So my dear friends, over here, do you realize what are the species that you have? You have a +4 species, another +4 species, another +4 species. Out of these 3 species, which one wants to capture the electrons? Out of these, which one wants to capture the electrons? देखो, we just understood on the previous page that lead 2 positive is pretty stable. Lead 2 positive is pretty stable. So do you realize that lead 4 positive would want to turn into lead 2 positive because of the inert pair effect? Yes. So that is why PbO2 is the strongest oxidizing agent over here. ठीक है? This is why. This is because of the inert pair effect. So पहले का आंसर हो गया lead oxide. चलो. Next case, which of the following has the maximum number of unpaired electrons? People, quickly, this is a question from atomic structure. फटाफट से बताओ, which one of these has the maximum number of unpaired electrons? ये तो घटिया क्वेश्चन है यार. Yeah, is a useless question. बताओ. फटाफट. Quickly, tell me. Yeah, चलो. Anyway, इसका आंसर बताओ आप चैट बॉक्स में. Let's look at the next question. The incorrect statement among the following is. This is a good question. This one is very easy. I'll receive your responses in 10-20 seconds. Anyway. Okay. I am getting mixed. Magnesium कहाँ से आ गया अर्षा? I am getting mixed responses on this question. क्यों भाई? Obviously यार, मैग्नीशियम 2 पॉजिटिव में नो अनपेयर्ड इलेक्ट्रॉन, टाइटेनियम 3 पॉजिटिव में 1 अनपेयर्ड इलेक्ट्रॉन, वैनेडियम 3 पॉजिटिव में नो इलेक्ट्रॉन, आयरन 4 अनपेयर्ड इलेक्ट्रॉन्स. या चलो. द इनकरेक्ट स्टेटमेंट अमंग द फॉलोइंग इज द फर्स्ट आयनाइजेशन पोटेंशियल ऑफ एल्यूमिनियम इज लेस देन द फर्स्ट आयनाइजेशन पोटेंशियल ऑफ मैग्नीशियम. माय डियर फ्रेंड्स, डू यू रिमेंबर व्हाट वी हैड डिस्कस्ड? ये वाला ट्रेंड याद है? सोडियम, मैग्नीशियम एंड एल्यूमिनियम. Do you remember this trend? Yes. So over here what's going on is that because of magnesium's fully filled configuration, it does not want to lose the electrons. Yes, उसको electron lose नहीं करने का है. So the first ionization potential of aluminium is less than the first ionization potential of magnesium. Absolutely correct. This is not the answer to our statement. Then it says the second ionization potential of magnesium is greater than the second ionization potential of sodium. अब इसका क्या मतलब हुआ? सेकेंड आयनाइजेशन पोटेंशियल ऑफ मैग्नीशियम इज ग्रेटर देन द सेकेंड आयनाइजेशन पोटेंशियल ऑफ सोडियम. It means that we are trying to define the ionization potentials of one positive ions. In the second case, we are comparing Mg positive versus Na positive. Now, my dear friends, if you realize Na positive is already a noble gas configuration. Isn't it? Sodium positive is already a noble gas configuration, but magnesium positive can easily lose an electron easier to remove an electron, right? So यहाँ क्या बोले, second ionization potential of magnesium is greater than the second ionization potential of sodium. Second ionization potential of magnesium will be lesser than second ionization potential of sodium. So this seems to be the answer to our question. This particular statement is incorrect. Yeah, let's look at the third statement. The first ionization potential of sodium is less than the first ionization potential of magnesium. That's correct. Third ionization potential of magnesium is greater than the third ionization potential of aluminium. Yeah, true, because aluminium wants to lose the third electron to become Al3 positive relatively. Magnesium not so much. ठीक है, fine, awesome. तो ये हो गया. Answer is option number B. चलो बढ़िया. My dear friends, let's do this question. This is a very beautiful question. Identify the least stable ion amongst the following. This is a good question. Identify the least stable ion amongst the following. कौन सा होगा least stable? Let's try to understand. First you have Li positive. Li positive, what's the electronic configuration? 1s2. Then let's look at carbon negative. What's the electronic configuration? 1s2, 2s2, 2p3. Right? Beryllium negative and boron negative. फटाफट से इनकी electronic configuration लिखो. You don't even need to go to electronic configuration, by the way, to think about the stability of these ions. Okay, it's very easy to figure out the stability without the electronic configuration. So boron's electronic configuration will be 1s2, 2s2, 2p2, and beryllium will be 1s2, 2s2, 2p1. So my dear friends, I hope you understand that this is pretty stable because it's a noble gas configuration, helium configuration. Carbon negative, we can say that this configuration has a half-filled nature to the p subshell. So this is also going to be a relatively stable configuration. Chalo, that reason is fine. Let's try to compare between beryllium and boron. Yeah, let's try to compare between beryllium and boron. What is going on? यहाँ क्या चल रहा है? That is what matters for us. देखो. Simply try to compare the number of electrons versus protons. Okay, understand both of these species, beryllium and boron, okay, both of these species have one extra electron, isn't it? दोनों species में there is one extra electron. Let's try to figure out what are the number of protons in each case. Beryllium में what are the number of protons? 4 protons. Boron में how many protons are there? 5 protons. Now my question to you is very simple. मेरा क्वेश्चन बहुत सिंपल है. माई क्वेश्चन इज इट ईजियर फॉर 5 प्रोटॉन्स टू हैव 1 एक्स्ट्रा इलेक्ट्रॉन और इज इट ईजियर फॉर 4 प्रोटॉन्स टू हैव 1 एक्स्ट्रा इलेक्ट्रॉन? बताओ. टेल मी, इज इट ईजियर फॉर 5 प्रोटॉन्स टू हैव 1 एक्स्ट्रा इलेक्ट्रॉन? इज इट ईजियर फॉर 4 प्रोटॉन्स टू हैव 1 एक्स्ट्रा इलेक्ट्रॉन? 4 protons, less total nuclear charge, less effective nuclear charge, 1 extra electron, very bad. 5 protons, a little better than 4 protons, more total nuclear charge, more effective nuclear charge, easier for it to have 1 extra electron. Easier. I'm not saying it is very good. It's relatively easier than beryllium. So my dear friends, beryllium negative is the least stable ion amongst the following. ठीक है, very typical question. I think it's a previous year question from JEE Advanced maybe. Beryllium negative is the least stable ion amongst the following. ठीक है, very nice, very simple. Now let's move on to the next page. Last page of this particular chapter. Let's do the first 2 questions. Last question at the bottom over here. This one is your homework. इसको एक बार लिख लो please. Take a screenshot. Write it down, whatever you want to do. You can write it in a little while. Let's solve the first 2 questions. पहले 2 question तो आसान है. The energy released when an electron is added to a neutral gaseous atom is called. बताओ, पहला वाला तो simple हो गया. Yeah. Purnima is saying, so please give a strategy for 2022. Purnima, I've already done that on my channel. So if you just go to the homepage of this channel, scroll down, there will be a playlist called How to Prepare Chemistry. In that, I've made a video for 2022 students, 2021 students. Please make sure you watch that. Okay? Arjun is saying, what about C negative? Arjun, once again, carbon has 6 protons to capture an extra electron will be even better for it compared to all the others. Yeah? चलो, तो ये क्या है भैया आंसर इसका? घटिया. Electron affinity. Yeah, we are talking about energy released. We are not talking about the enthalpy change. We are talking about the energy release. So energy released is known as electron affinity. ठीक है? Very nice. Next, arrange the following in order of decreasing ionic size. ये तो अपन ने किया ही था. Do you remember? This is a question that we've already done. So decreasing ionic size, highest ionic size will be for O2 negative, then F negative. It's larger than sodium positive, which is larger than magnesium 2 positive. Fine. We know that already. Next question is, arrange the following in increasing acidic property. So my dear friends, over here we have oxides. Oxides के case में what did I tell you? More metallic, more basic. Less metallic, more acidic. So over here, P2O5 is going to be the most acidic. Then you're going to have zinc oxide. This is in fact an amphoteric oxide. Please remember, zinc oxide is amphoteric in nature. Then you're going to have magnesium oxide, and then you're going to have your sodiums. ठीक है? Done? Fine? Got it? बढ़िया. This is a peroxide. This Na2O2 is a peroxide. Cool? This is your answer. Zinc, you should remember, is amphoteric in nature. And the species that is on the leftmost side, this is called sodium peroxide. Okay? Cool? Great. So this is done. Awesome. So people who do not understand this particular question, ये जो ionic size जिसको नहीं समझ आया, people please watch all the regular classes. Okay? If I start telling you the same things again and again in each and every class, it will be difficult, right? I'll give you the hint. All of these species have 10 electrons each. More protons will hold these electrons closer, less protons will hold these electrons further. Oxygen has only 8 protons, electrons will be far away. Fluorine has 9 protons, electrons closer. Sodium has 11 protons, electrons even closer. Magnesium has 12 protons. 12 protons versus 10 electrons. Electrons will be very close to the protons because there is so much positive charge. So in an isoelectronic species kind of a case, more protons imply lesser size. Okay? That's the reason. Cool? Awesome. So my dear friends, this last case is your homework. Please make sure you note it down. एक बार इसको लिख लो. Okay? You can take a screenshot as well. I see a lot of random stuff going on in the chat box. Vedantu, Unacademy, Byju's. भाई जो पसंद है वहाँ जाओ ना. Whatever you like, go there. As simple as that. Suzanne is saying, good evening sir, I am late. Suzanne, no, you are not late. You are just early for the next class. Cool people. Awesome. तो ये हो गया अपना आज का क्लास खत्म. Yeah, we're done with today's class. So my dear friends, this was the chapter of periodic properties. We are done with this chapter. And I am not sure how good this very first class on the smart board was. पता नहीं, देखते हैं. Let's see if you have any views on the smart board, if you want me to change to the old setup, if you like this new setup, please tell me in the comment section down below. Let's see what everyone has to say. If you enjoyed today's class, then make sure you hit that like button. I'll look at the chat box for 2-3 more minutes and then I will call it a day because I'll eat something and prepare for the next session at 8:30. ठीक है, चलो. Cool. So next chapter for all of you 11th class students who are wondering क्या होने वाला है, next chapter will be the chapter of chemical bonding. I will most likely start it on Saturday. ठीक है, most likely Saturday को start होने वाला है. Sukh is saying you teach better on the smart board. Okay, Sukh. Bharat, not a problem. You can watch the class from the beginning. Sri Ram is saying, is that from nuclear chemistry? It is, but it's very logical. You just have to conserve the numbers that are on the top and the bottom. बड़े आराम से हो जाएगा. The convention of writing the electronic species we have learnt in the chapter of atomic structure, है ना? ठीक है. Okay, Karan is asking what's at 8:30. Bro, at 8:30 we are going to solve the NT Abhyas mock test 37 of JEE mains. Okay, entertainment 2015 is saying, sir, please say about 2021 syllabus. What do you want me to say, bro? कोई ना comments में बताना after the class is over in the chat box. Hardly I can see how many people are sending a message or not. But the interesting thing is that today 157 people are still watching the session. Generally we are, you know, at somewhere around 80-85 students maximum. So I don't know if it's because of the smart board, if it's because the exam has been postponed, so everyone just wants to watch all the sessions, etc. Janvi enjoys my classes regardless. Thank you so much, Janvi. Great. Badhiya, badhiya, badhiya. Rufus is saying so most chapters are deleted for CBSE. We'll see what's going on with that, man. देखेंगे क्या हो रहा है उसके हिसाब से. Ghanshyam, thank you so much, man. Thank you so much. बढ़िया. चलो. So people, that's it for this class today. Thank you so much for joining in. I hope you enjoyed the entire chapter. If you haven't seen the earlier videos of this chapter and if you want to improve the chapter of periodic properties, please make sure you do so. The link of the playlist will be down in the description box. Also, do not forget to join the pro course in case you want to join Vedantu as a regular full student. Then you can join the pro course. The links are also in the description box. So thank you so much. I'll take your leave. Until next time. Bye bye. Take care. See you soon.